Okay, today we're going to be taking a look at lesson 3 out of chapter 6, and we're going to be estimating fractions, sums, and differences. So what we're really going to be doing is we're going to be using benchmarks to help us to make estimates of adding and subtracting fractions. One way that we can do this is we can look at a number line. So here's our number line, and you can see that on our number line we've identified our 3 benchmarks, and our benchmarks are 0, 1/2, and 1. So if we look at this number line and we look at our problem, which is 1/6 plus 3/8, we're going to chart or we're going to mark one of these on our number line. And we see that 1/6 is right here, and 1/6 is closest to our benchmark of 0. So that would mean that in our original problem, estimating, we would say that 1/6 is about the same as 0. So now we need to find out, well, what's our benchmark for 3/8? We're going to take and we're going to make another number line, starting with 0/8 going up to 8/8. And here we are, we're going to plot 3/8 on this number line. And for this one, we can see that 3/8 is closest to 1/2. So 1/6 was about 0, 3/8 is about 1/2, and so 0 plus 1/2 equals 1/2. So we could say that our estimate for the problem of 1/6 plus 3/8 is about 1/2. Now, is it exactly 1/2? No, but it's pretty close to that. An alternative way that we can do this is instead of having to draw a number line all the time, we can draw a model. So if I were going to do this problem over, I would think about this in terms of drawing a model of 1/6. So if I drew this model of 1/6, it would look like this. Now, after I draw this model, I'm going to think to myself, is this model about completely full, which would be 1? Is it about half full, which would be 1/2? Or is it almost empty, which would be 0? And when I see that there's only one out of these 6 boxes shaded in, I think to myself, well, this model is almost empty, and so my estimate for, or my benchmark for 1/6 would be 0. I could do the same thing for 3/8. And here, I'm going to shade in 1, 2, 3 of my 8 pieces, right? And I'm going to think through the same thing. Is it almost full, about half full, or almost empty? When I look at this top row here and I see that it's only missing one piece over here, I think to myself, well, this model is about half full. So here we are. Again, same result is 0 plus 1/2, which equals 1/2. So that's how I like to think about this. Hopefully, as you do a bunch of these, you'll start to notice that you can also just sort of think about it in terms of what is half of my denominator, right? Half of 8 is 4, which is why we end up with 4 boxes across the top. Half of 6 is 3, which is why we have 3 boxes across the top on this model. And so once I identify what's half of 8, then I can compare my numerator to that half, right? So how does 3 compare to 4? Well, 3 is really close to 4, which is why we came up with an estimate of about 1/2. And then I compare 1 to 3 because 3 is half of 6. And I say, oh, well, 1's not really the same as 3. And so that is why we ended up with 0. So those are the ways that we use our benchmark, right? So let's take a look at some other problems and see if we can apply this. Here we are. We have this same idea, and again, we can use it any of those 3 methods, but we need to pay attention to the fact that we are subtracting for this problem. We are not adding. So we have 9/10 minus 5/8. So the first thing I'm going to do is I'm going to look at 9/10, and I'm going to think, oh, well, 9 is almost 10. So if 9 is almost 10, then that means that if I were to draw a picture of 9/10, right, I would shade in 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And because 9 is almost 10, it means that we're only missing one box, which means that this model is almost full. So that's 1. Then I look at 5/8 and I think to myself, well, let's see, half of 8 is 4, and 4 is about 5. So I bet when I draw this picture that I'm going to see that it's about half full, right? So there's 8 pieces, 1, 2, 3, 4. There's half. Then I just get one more on the bottom. So again, my guess was right. My feeling that 4 is about 5, so this would be about 1/2 works out. So I end up with an estimate, a benchmark of 1 for 9/10 minus 1/2 for 5/8, and 1 minus 1/2 means that I am left with just 1/2. I'm going to apply this to one more type of problem, and then you're going to give it a go on your own. So here we are. Here we have mixed numbers, right? So a mixed number is where we have a whole number with a fraction. And when we do this type of problem, we are not going to worry too much about the whole number. We're not going to use a benchmark to estimate that. We're just going to use our benchmark for our fraction. So I'm going to have 2 and 7/8 minus 2 and 1/2. So when I start thinking benchmarks, I'm only going to look at the fraction. So 7/8. 7 is almost 8, which means that this fraction has a value of 1. Now, I said we weren't going to look at the whole number, but that's only when we're doing the benchmark part of this. We still need to think about this whole number because the number is not 7/8. The number is 2 and 7/8. And when I think of the word and, I think of addition. So I'm going to think of 2 plus 7/8 would be 2 and 7/8. So when I find my benchmark of 1, I'm going to think, oh, well, it's like I have 2 plus 1, and 2 plus 1 would equal 3, right? So 2 and 7/8 is about the same as the number 3 because 7/8 is about the same as the number 1. So we'd put those together. Now I'm going to subtract from that. And again, I need to look at my fraction to figure out my benchmark. Well, this one should be pretty easy because 1/2 is about half, right? I mean, we don't even need to find a benchmark because it's already a benchmark. So I end up with 3 minus 2 and 1/2. Well, if I have 2.5, then I just need 1/2 more to equal 3. So this is my answer for this one. 2 and 7/8 minus 2.5 is about 1/2. Let's erase this, and then let's apply that same thing to the other problem on this page and see if we can figure it out. All right, so here we have 1 and 8/9 plus 4 and 8/10. So again, I'm going to write it out. 1 and 8/9 plus 4 and 8/10. I'm going to use my benchmarks. 8/9. Well, 8 is almost 9, so this is worth 1. Right, but I already have the whole number here of 1, so it's like I have 1 plus 1, which equals 2. So 1 and 8/9 is about 2. Do the same thing here, 8/10. I'm pretty sure that that's about 1, but I'm going to just like draw a picture to double check this. 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5, 6, 7, and 8, right? So I'm only missing 2 of these boxes on the bottom. So I'm going to go ahead and say that this is about 1 as well. So I end up with a whole number of 4 and a fraction that's about 1. So I'm going to say that 4 and 1 is 5. So I have 2 plus 5, and 2 plus 5 is 7. So 1 and 8/9 plus 4 and 8/10 is about 7. All right, so that is our lesson for today. Again, our benchmarks are 0, 1/2, and 1. We can apply it to adding fractions plus fractions. We can apply it to subtracting fractions and fractions. And we can apply it even when we have mixed numbers to help us to simplify this process. So give some problems a try. Let me know if you have any questions.